In the last set of videos, we got to learn about buoyant force and that it's an upward force. And with this basic understanding, we will be able to understand Archimedes principle. So what is the basic idea behind the principle? It talks about how much force does an object experience when immersed in a fluid. See, we saw that when we keep an object in any fluid, it will experience an upward force, right? But we didn't talk about how much force, is it not? The quantity, because force is quantifiable. We can measure it, right? So the question of how much will be answered by Archimedes principle. So basically it will help us measure buoyant force. Agree? Okay. So let's see the statement. What he tells. When a body is immersed fully or partially in a fluid, okay, it experiences an upward force. Till here we are clear with, not an issue. This is equal to the weight of the fluid displaced by it. This is where the key thing lies. See, whenever we dip any object in any given fluid, what happens? It will push the liquid away or the fluid away. So the amount of water or any liquid it pushes, right? That amount, if you calculate the weight of that fluid, that would be the force that the object experiences. Okay, so let's make it clear with an experiment. If you're not able to get this, we'll make it clear with an experiment. The basic funda over here is to understand Archimedes principle. The procedure is as follows. Tie a given solid with a thread and suspend it from a hook of a spring balance. Note down the reading of the spring balance. So the weight that we are using here is something like this. And we'll be tying that to a spring balance. What we can see over here is part of a spring balance. So this will help us measure the weight, basically, mass. This will help us measure the mass. Next thing, place a graduated measuring jar and fill it with water partially. Measure the water level in the jar. So graduated measuring jar is something like this. We have a jar which has some marking like this. For example, over here, can you see this? There are markings. Right, this is a long marking and we have 200 written over here. This is again a long marking. It is 250 over here and in between there are 5 of it. Right? So each of this is a milliliter, 1 milliliter. And it's equal to 1 centimeter cube. This conversion is important. Okay, it will help us calculate things. So this is important. So basically over here we have 200 milliliter, if not 200 centimeter cube of water. This is important. Okay, so you need to have a mental note of this. Okay, we have done two things. We have a mass which we weighed, right, which we found the mass of. We have an object, that is, we found the mass of that, and we have a container filled with water which is graduated, that is, it is marked, and the marking is at 200 milliliter. Now what is that we are doing? Next step, clamp the spring balance with the stand, slowly immerse the solid into the jar. So we are letting the object inside the jar. Note the reading of the spring balance now. Again we are measuring the mass over here. Measure the water level in the jar. So obviously when we dip something, the water level increases, right? Over here from 200 it has increased to between whatever this value is. We'll measure this value in a second. Okay guys, so this is the procedure. Repeat step 1 to 5, not 2, with different mass. The same thing we are doing with different mass. And now you guys have to have a look at this particular video. Please have a look at this. Okay, are you able to get what we did? So I hope you guys had a proper look at it. So now if you want to read the procedure again, you can read it so that you concrete the idea what we did. So if you have done that, we have to read the measurement. We didn't do that in the video, is it not? It was not easy. So I've taken photo of all of that and we're going to have a read through. So we're going to measure things over here, write it down, and end of it we have to fill this table, and that's how we can conclude. Okay guys, so let me show you guys how to read. First I'll help you guys read the water level. So you can clearly see along this level is where the water is lying, is it not? And this is 200. The marking is 200, means what? This is 200 milliliter, if not centimeter cube. Any one of this. Same thing. You got it, guys? It's the same thing. It's important for us to understand that we can measure in both. Done. Next thing. Here, it's around, this is of 50 grams. This is around 45 grams. Okay, I'm also writing it down, not only on the screen, on a sheet of paper. So this is 450 grams. And this has increased after dip. See, this is before dip. This is the very first set. This is the second set. There are like 4 sets with different masses. Right? So it has moved from here till 1, 2, 3. Is it not? So this would be 45, 40, 35, 30. Agree? So this is moved till 30 gram. Okay, guys. And here we have it has moved from 200. This is 210. This is 200 and not 10. Yeah. 210, 220. It's in between that. It's around 215. This is what? Milliliter, if not centimeter cube. Okay, I'll write it in centimeter cube. Next one. Can you guys try it? So this is 75. Okay, this is one marking and one marking, and each of this marking is of 5 grams. And this is 50, and this is 45. Again, all of this is 5 gram. So please read this, and here is your 200, and it's over here. The water level is over there. Are you guys able to do that? So what is happening over here? We have it to be 75, 70. Okay, let me also read it. Let me erase this first. Okay, so clearly this is 75. Let me start over 75, 70, 65. So this is 65 grams. This is 50 and this is 45 grams. This is 200 and this is 220 centimeter cube. Okay, guys, 220 centimeter cube. In all of this experiment, the initial reading of the jar water content is 200. It was at 200. Now things have changed. This is the third set and the fourth set. Please try to read the values again. I know it's not very practical, but try. Your 25 marking is over here. 25 marking is over here, and for this the 100 marking is over here, and the 100 marking is over here, and there are 2 markings, almost 2. It's in between. Okay, so let me do this. Here we have the 25 to be over here, so it is moved from 25 grams to 2 places, so 20 and 15. So this is reduced to 15 grams. Obviously it will reduce, right? And the water level has increased to 210 centimeter cube. Agree? And over here we have this to be around 95. No, this is 105. It's below, right? 105 grams. It's moved to 195. Around 95 to 90, 97 grams, 97.5. Let me take the 98 grams actually. It's in between, somewhere in between. And the water level has increased to 210 grams. Okay, guys. And next is we have to make a note of the values and try to figure out what is the value telling. The density of the fluid that we are using is around 1 gram per centimeter cube. Okay, see, this is water, tap water. So you can approximately take that it will weigh 1 gram for every centimeter cube. And acceleration due to gravity is 10 meter per second square. Right? So now it's time to fill the things up. So let me do it with, let me see if this works out. This color works out. Let me try this. So this is 45, this is 30, 65, 45, 25, 15, 105 and 95. Sorry, my bad. I need to read the table for you guys first. So we are looking at reading of the spring balance before dip and after dip in grams. All of this in grams. This is M1 and this is M2. And then we have to take the difference in this values and multiply with G, and so as to get the force in terms of Newton, weight in terms of Newton. For that we need to do the conversion over here. I'll show what is that conversion. Reading of the jar before the dip and after the dip, difference in the reading. Here too we need to convert it into the weight. Okay, the mass, not mass, weight of the fluid that has been displaced. For that we need to use this. What is this? I'll explain. So I need to explain what is this symbol. Okay, yes, I need to explain what is that symbol. Right, we'll come back to that. And we need to take the difference in apparent loss in weight and the weight of the displaced water. That is, we need to take the difference of this and this. These two columns. Right, guys? Okay, let me write the volume. So all this is 200 centimeter cube. And this is 215, this is 220, 210. And last one is also 210, this is 98. 98. And this is also 210. And now we have to take the difference. It's quite simple. 15. Oh yeah, we have to convert it to Newton. So these are in grams, by the way. So the difference is 15. This is in grams. How do we convert into kilograms? By dividing with 1000. Kilogram into 10 meter per second square. And all of this will give us the force. So 0 gets cancelled. 0.15 Newton. Understood how to convert? Next one. The difference is 20. Let me change the color actually. The difference is 20, right? But we need to convert it to kg. These are in grams. So divided by 1000 kg. 10 meter per second square. So 0, 0, 0, 0. So this is 0.20 Newton. Okay, guys. The next one would be difference is 10. Same thing, 10 by 1000 kg into 10 meter per second square. So 2 zeros and this 0.10 Newton. And the last one is the difference turns out to be 567. 0.07 Newton. Agree? Is that correct, or I'm not very sure of this value. This is below 100, so this is 105. Okay, that I have written right. This is 100. This is 95. Oh yeah, sorry, this is not 98. It's closer to 95 and this is closer to 90. It's around 92 grams. 92. So difference is around, what is the difference, guys? 10, 13, is it not? So this would be, I'll directly write it, 0.13 Newton. Agree? And this now. So difference over here is, oh yeah, I didn't tell you this symbol. This is nothing but rho. This is read as rho. It represents density. The concept of density is quite simple. We'll be studying about this and we'll be studying such calculations a bit later. But now you just have to go with the flow. Okay, guys, I'll just show the major working over here once so that you get a good glimpse of what we are trying to do. V2 minus V1 is 15. That I won't show the difference. Density here is, this is 15 centimeter cube. I need to show the unit as well. Density is 1 gram per centimeter cube. 1 gram per centimeter cube into acceleration due to gravity, that is 10 meter per second. Second square. So here we have centimeter cube, that gets cancelled. And the multiplication over here is 150. But this is in grams. We need to convert it to kg. 1000 kg meter per centimeter square. See, same thing, kg meter per second square. Not centimeter square, second square. This is nothing but your Newton, right? So that makes up 1 Newton. So this is basically 0.15 Newton. Okay, guys. So I'm directly writing the answer, 0.15 Newton. right? Whatever the difference is, just divide with 1000, you will get the answer. So this is 0.20 Newton, this is 0.10 Newton, and this is also 0.10 Newton, right guys? Please understand this calculation. It's over here, right? Okay, happy with this? If you're finding all of this difficult, learn from the basic videos how to convert units, kg to grams and grams to kg. It's very simple, it's not too hard. And at last we are trying to find the difference. The first column is over here and the second one is over here. We have to find the difference. So 15, 0.15, 0.15, 0 Newton. Here to it's 0 Newton. Here to it's 0 Newton. Only difference over here is 0.03 Newton. This is the only place we are getting some weird value. This is not clear now. 0 Newton, 0 Newton, 0 Newton, 0.03 Newton. Okay guys. So what is that we got to learn? We can conclude the following. Please conclude. Please have a look at this. Fill in these blanks. Right? I hope you guys did. I hope you guys read through this. The difference between the apparent loss in weight of a solid, that is, it appears to lose. This apparent is not actual. Apparent means it looks like, right? So it looks like the object lost some weight all of a sudden, is it not? Before the dip and after the dip, what is that we are seeing? It moved from 25 grams to 15 grams. Apparently there is a loss of 10 grams. How is this possible? How is it suddenly that this particular mass is losing 10 grams? Because it is in the fluid and fluid is pushing it up, right? Agree? So there is apparent loss in weight. It's not actual loss, apparent loss. Is it not? It looks like. It looks like. Loss in weight of a solid when immersed in water and the weight of the water displaced is negligibly small. And we can see that on an average, if I divide this with 4, this would be 0.0075 Newton. This is your on average. This is the change in weight, matlab difference in weight that we got from all of this experiment. This is something that I didn't do right, I guess, while taking photo, or maybe I shook something. If not, you would have got 0. In each case, the observed value of the apparent loss in weight of the solid immersed in water is nearly equal to the weight of the displaced water, is it not? We're getting the same weights, right? This verifies Archimedes principle. That's what he told, right? Whenever you immerse anything, there will be some loss of weight, apparent loss in weight. And that loss in weight, see, remember, weight is nothing but force, is it not? So that force, where did it go, disappear to, or where did it go? That is being supported by the water, the fluid. Is it not? Agree? Right? And that's what he told. When a body is immersed fully or partially in a fluid, it experiences an upward force. That we know. And this force, the amount of force is equal to the weight of the fluid displaced by it. So in each of this column, right, with each of this column, we saw this, all of this. First, we saw that the loss of weight, the loss of weight of the object after dipping and before dipping. We saw the difference. And we saw the amount of water, right? The amount of water that was displaced. How? We found before and after the dip. In the graduated scale, we found that. And we found this is the amount of water, the weight of the water that is displaced. Is it not? All these values are nothing but the weight of the water that has been displaced. I hope you guys understand this. This is nothing but weight of water displaced. Is it not? And the difference will give us the conclusion. We are able to conclude that yes, this is true. As simple as that. This is a verification for Archimedes principle. Okay guys, all you guys have to do is write only the left hand side. Everything else was for your understanding. I hope you guys liked it, and you guys can also do this. The same thing. You guys will get the material, and you guys can get the table also. Right? But yes, unit conversion is difficult. I agree. I understand. especially all of this and grams to kg. You find it difficult, but again, don't be lazy. Everything is ready for you guys to learn. It's a matter of you guys putting in effort to learn. Okay, so now pause and write the principle.